Hi everyone, I'm Snigdha Kakkar and this is my channel AccelerateAICareers. Today we are going to solve a very interesting LeetCode problem. LeetCode 72, edit distance, has been an all-time favorite for Amazon, Google and Microsoft in last 6 to 12 months for their interview rounds. So let's see what does this question say. You have been given two strings, word 1 and word 2. You have to return the minimum number of operations which are required to convert word 1 to word 2. There are three operations you can use. Either you can insert a character in word 1 to get it equal to word 2, or you can delete a character, or you can replace a character even. So let's see some examples. So for example, 1, you have been given input word 1 as horse and word 2 as Ross. First of all, you strike out H and instead of H, you get R. So the first two characters become equal. Then you remove the third character because there's already an S. So you just delete R, you already have S. And then you delete E. So there are three operations you made. You got rid of H and got R in this place, so you did a replacement. Then you deleted the R in the second index, okay? And after that you deleted E. So basically you did three operations here as shown. So instead of horse, you got Ross after replacing H with R. Then in rows, you deleted R, so you got rows. And then in rows, you deleted E, so three operations. So that's the minimum number of operations you would do to get word 2 from word 1. Now let's look at another example. So here, word 1 is intention and word 2 is execution. You can do the steps, whether it's insertion, deletion or replacement in any order, right? So what they have done is first they have gotten rid of this T in the second index. And from intention, the word became ination, so they removed T. Then in the first place, you have I, so they got rid of that I. Instead, they got an E to move towards execution. And then in ination word, in first index, second place, you have an N. They got rid of that N, replaced it with X, so exention. And then in place of this N, at third index, they got C. So you got execution, and then you just insert a U after C, so you get execution. So you can see that there are 5 operations done. Hence, the minimum number of operations to go from word 1 intention to word 2 execution would be 5 as shown here. Now let's look at some of the examples of my own to understand the approach we are going to use to solve this question. So here, I have taken word 1 as an empty string and word 2 also as an empty string. What do you think will be the number of operations required, minimum number of operations required to go from word 1 to word 2? 0, right? Because they are kind of equal. They both are empty strings. So 0 steps required, 0 operations. Now let's look at another example. Your word 1 is ABC and your word 2 is also ABC. In that case, how many steps will it take to go from word 1 to word 2? So since they are equal, it takes 0 minimum operation. So this is one of our base cases when both the strings are either null or both the strings are equal. In that case, 0 minimum operations. Now, what if your one of the strings is null? Your word 2 is null and your word 1 is ABC. So you have to go from ABC to null. That is, you have to do 3 deletions, but it's possible, right? And how did you figure out that you have to do 3 deletions? Because length of word 1 is 3, whereas length of word 2 is 0. So you have to go from 3 to 0. Hence, the number of operations required, minimum number of operations required would be length of non-zero word, which is word 1, non-null word. Whichever string is null, that word's length would be the minimum number of operations you would require to go from word 1 to word 2. Let's look at the reverse scenario. Your word 1 is null and you have to go to word 2, which is ABC. So you have to do 3 insertions of A, B and C. And how did you get the 3? By length of non-null word string, which is word 2. Now what if you have word 1 as ABD and your word 2 as ACD? The brute force approach would be that we start at the 0th index, okay? Or I would say that I would take I pointer to go from word 1, 0th index to nth index. And I would take j pointer to go from word 2, 0th index to nth index. Now I will start comparing from 0th index. So I will check for word 1 I and word 2 j, where I and j are 0th indexes. Now I see that word 1 I is equal to word 2 a, like both are a, right? So in that scenario, what do? we go to the next letter. We check for word 1B and word 2C. So basically, whenever your ith character in word 1 and jth character in word 2 are same, your result will depend upon word 1 I plus 1 and word 2 j plus 1. I hope you understand that. So you come to the second index, the first index, word 1 I is B there and word 2 j is C there, which are not equal, right? So you can do 3 steps in brute force as indicated by the question. Either you can do insert. If you have to do insert, then how do you insert? So if I have to insert C here between A and B, I bring a C. Say suppose I bring a C here. So bringing a C will lead to ACBD, whereas your word 2 would be ACD. Now when you have inserted a C here, your word 1 I index will still be at B, right? It will be at ith index only. You will not increment it. You will start comparing B with D now, okay? Because you already got C in word 1, which is equal to C in word 2. So now you compare B with D. So your B will still be at ith index. But word 2, your jth index will increment and go to D, that is j plus 1. So whenever you try out insertion, you increment only the pointer for the other word where you are not incrementing. Now let's practice deletion. So your original string was ABD. So instead of inserting a C, you chose to delete letter B from word 1. So if you delete this, you have letter AD, okay? In deletion, you automatically move from I to I plus 1th index, which is D, right? But you would compare this D with C. So your jth pointer still remains at C, whereas your ith pointer increments in deletion. So in deletion, it's I plus 1 j. You check for minimum number of operations to convert word 1 I plus 1 to word 2 j. Okay, you compare those. Now, what if I don't delete? Instead, I do replacement. So to replace from B to C, after if I have replaced B to C, in that case, I will check for the next character, which would be D, which is I plus 1, and D here in word 2, which is j plus 1. So you will compare I plus 1 and j plus 1. So if you see, replacement is almost identical in steps to this place when word 1 was also null and word 2 was also null. Because in that scenario also, you were just, since you had both the strings equal, you move to next indices. Same way, here when your word 1 and word 2 had all the letters similar, what did you do? You checked for I plus 1 and j plus 1th index. So that's what you do when you have done the replacement. But there is one difference. Here, the minimum number of operations required to do any step to go from word 1 to word 2 was 0, whereas the number of steps in replacement are 1. So you are essentially taking at least one operation to do this replacement, and the number of steps is not null as compared to when word 1 and word 2 are the same strings. I hope you understand this approach. So here I have taken my dynamic programming array, and I have taken the previous example which we just saw, where word 1 is ABD and word 2 is ACD. So as you can see, my array which I have taken is of length 4 by 4, where each of the words are of length 3. So why is it the case? Because I am taking into consideration my base cases. My base cases are what? My base cases are when either both the strings are empty or one of the string is null and the other string is not null. So those are my base cases, and for accommodating them, I have to take one letter plus in length when compared to the length of the word. And hence the DP array is 4 by 4. But where do we start from? Do we start from here or do we start from here? Where do we start from? So first look at our base cases. So here our string A, word 1 is also 0 and word 2 is also 0. Since both are null, in that scenario, the minimum number of operations required to go from word 1 to word 2 would be 0, and hence 0 here. Now here, when you have ABD, that is 3 letters, and you have ACD, that is 3 letters, you would say. But if you're looking here, the letter in word 2 is null, whereas the letter in word 1 are 3, ABD. So to go from word 1 to word 2, you have to delete these 3 letters, right? So hence the length of the word 1, which is not null, 3 here. Now here, your word 2 is still null, but your word 1 has 2 characters remaining, BD. So hence length of the remaining not null characters 2 here. Similarly, word 2 still is null here, but word 1 has a D and nothing beyond it, so one character. That's how we have got this. Similar to that, we'll fill out the last row here. When your word 1 is actually null, but your word 2 is not null, so you will be taking length of remaining characters and plotting it here, because those are the number of operations you would need to do. Whether it's insertion, replacement, or deletion, that doesn't matter. You need minimum number of operations, so that's what I have done here in the base case. This is something which I explained through examples before, so I hope that is clear. So you have last column and last row, which are your base cases, filled out. Now where do you start filling from? Do you start from here? Let's start from here and see. So you first check that your character A and character A here in word 2 are same. So hence number of operations required to go from here to here, you would say that it's 0. But you remember that I told you that word 1 I and word 2 j, if they are equal, we check for word 1 I plus 1 and word 2 j plus 1, this condition. So hence, if this condition we have to follow, we cannot put 0 here. We have to check for word 1 I plus 1, which is B, and word 2 j plus 1, which is C. And we check for it here in the diagonal value. So, and so on. So we will check that B is not equal to C. So we will require 3 of these operations, either insertion, deletion, or replacement. So when you check minimum number of operations, you have to check minimum of steps required in insertion, deletion, and replacement. So for insertion, it's I, j plus 1. So you basically, when you insert, you keep I intact, but you move the j pointer. That's what we saw in the examples. For deletion, you keep the j pointer intact, but you move the I pointer. And for replacement, you move both I and j pointers. So you take the minimum of operations required for these 3, and that's what the value comes here. So insertion is I, j plus 1. That is, your I still remains in the same row, but j increments by 1. That is, you check for the next value in the next column. For deletion, you check for the value just below it, because you increment the row but keep the column same. For replacement, you check the value to the diagonal of it. That's how you are going to place some value here. You're going to check this, then this, and then this. And you're going to take minimum of these. That's how you get the minimum number of operations here. But then for getting minimum of number of operations from here, you need value here, here, and here, which you don't have. So then you check from here and first plot this. And then you get this value and this value. So I would suggest, instead of going from top down, go from bottom up, because you anyways need this value, and this value to fill out this value. So it sounds more to follow bottom up dynamic programming approach than top down. But how do you fill these values? So let's look at this value. In this value, you check that your word 1 I is D and your word 2 J is D, and they are both equal. So number of operations required is 0. Okay. And you can also check it by minimum of these three values. Okay. Now you move ahead. You check for this. For this, you need 1 plus minimum of these 3 values. That's what I'm going to say, because your B is not equal to D. That's what you're filling out, okay? 1 plus minimum of these is 0. So 1 plus 0 is 1 here. Similarly, to fill out this, you check that word 2J is C, word 1 I is D, and to compare them, you need to check for 1 plus minimum of these 3. So minimum of these 3 is 0, so 1 plus minimum of these 3 would be 1 here. Now to fill out this, you take minimum of these 3 and add 1. Minimum of these 3 is 0 again, and you add 1, so you get 1 here. And that's how you can fill out the entire array. If your word 1I is equal to word 2J, you check for word 1I plus 1, J plus 1, that is the diagonal value for minimum number of operations. If in case it is not equal, you take the minimum of these 3 operation steps: insertion, deletion, or replacement. That is, you check for the value in the next column, same row, or next row, same column, or diagonal value. That's how you get the minimum of these 3 values and add 1 to it, because at least you're doing one operation or either of these 3. That's why I'm adding the 1 here. So I hope you understand the DP array approach here, and remember these. We'll be using these in our coding as well. Now I'm initializing my DP array. I have named it as cache, and I'll initialize by float infinity values for all the cells. And how many cells do I need? I need length of word 2 plus 1. And why do I need plus 1 here? Because I need one column and one row extra to handle my base cases, like I showed in my explanation for the algorithm as well. Okay, this square will come here. For I in range, length of word 1 plus 1. So that's how you initialize your DP array. Now I will loop through all the values of j in range length of word 2 plus 1 to fill out my base values. And my base values, you remember, in my DP array were 3, 2, 1 for the bottom row, and same way 3, 2, 1 for the rightmost column. So that's what I'm doing here. So I will update my DP array cache length of word 1, that is my bottom row, j. And what do I fill here? So I whatever the not null string is, that value gets filled here. So length of word 2, remaining characters of course, minus j. Because suppose you have ABD here and you have ACD there, and you are in the bottom row here and you are moving incrementally. So your value goes from 3 to 1, 0, right? So how do you get 3 there? Because length of word 2 is 3 at that particular cell. Then how do you get length of 2 here? So you get length of 2 because remaining letters in word 2 from that particular cell is 2. Then how do you get 1 there? Because there's only one character left, that is D. And hence I have done length of word 2 minus j. Because as you move the columns, your remaining number of characters changes for length of word 2. That's how I'm updating my base values. Same way I would update my base values in my rightmost column. So for that I would do length of word 1 plus 1, and I would update my DP array similarly, cat, and it would be I, and length of word 2, and I would update it as length of word 1, and remaining characters would be minus I. So I hope you understand how I filled out the base values. Now we will loop through the entire remaining DP array to fill out the remaining cells. So for I and we are doing it in bottom up manner, so we are doing essentially in reverse. For I in range, length of word 1 minus 1, because you have already filled out the bottom row, right? Minus 1, go till minus 1, and in decremental step also is minus 1. We would do for j in range length of word 2 minus 1, because you have filled out the last column, minus 1, go till minus 1 cell and decrement by minus 1 step. So now you are looping, and your conditions would be, you check if word 1 I is equal to word 2 j. If the characters in ith and jth place are equal, what do? You update the cache I, j with the values in diagonal, that is cache I plus 1, j plus 1. Because if your character at ith and jth place are equal, that is your word 1 I is equal to word 2 j, your minimum number of operations required will depend upon the values after it. So if word 1 I plus 1 and word 2 j plus 1 are equal or not, and how many number of operations are required there. So the value there, minimum number of operations there, will decide your minimum number of operations for cache ij, and hence I have done this. After that, else if your characters are not same, then you do either insertion, deletion, or replacement. You take minimum of that. So cache ij, and since you have to do at least one step, you add 1, and you will be doing minimum of. So for insertion, what do? Cache I plus 1 j. Same way you have to take cache I j plus 1, and you have to take the diagonal value, which is for replacement, cache I plus 1 j plus 1, and you take minimum of these three and add 1. And finally, what value do you need to return? You need to return the value of cache 0, 0, because you are going bottom up in the dynamic programming array, so you have to return the value of the 0th cell. Now let's run and see if this works. So it's accepted. Let's submit. So as you can see, our solution is doing really great here. I will summarize the code for you and then you should code it yourself to see that you understand the approach. If you have any questions, ask them in the comments. I'll be happy to help you out. If you like my way of solving these problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. It keeps me a lot of encouragement to make more videos. So now let me summarize this code for you. So you have to first initialize your DP array, which I have taken the name as cache here, and you are initializing everything with float infinity value. And you initialize for length of word 2 plus 1 because you need one additional row for your base cases, and same way for length of word 1 plus 1 because you need the last column and last row for handling your base cases. Now you loop around to fill in those base cases. So how do you fill in those base cases? One of those characters in either word 1 or word 2 would be null, and you would be taking the values for the length of not null string. That's what we do usually, right? So for j in range length word 2 plus 1, you're filling out the bottommost row. So we're essentially changing the column, but the row remains the same, which is the bottommost row. So length of word 1, j, cache, you are updating that by length of not null string, which is word 2 minus j. Okay. Same way you fill out the rightmost column by taking the value of I and range length word 1 plus 1 and changing that, and you fill out by taking length of word 1 minus I, that is remaining not null characters. That's what you do. Now you loop around in bottom-up manner in dynamic programming. You go in reverse. That's why you have started from length of word 1 minus 1 because you have already filled out the last row, and you go till minus 1 and take a step size of minus 1 for both I and j. And then there is an if condition whether word 1 I is equal to word 2 j. If it is true, then your minimum number of operations will be decided by your cache I plus 1 j plus 1. Else, if this value word 1 I is not equal to word 2 j, you have to either do an insertion or a deletion or a replacement. So you take minimum number of operations required between your diagonal value, which is for replacement, and your next column value or next row value, which is your insertion and deletion. You take minimum of operations required in these three and add 1 because at least you are doing one operation to handle this condition of word 1 I not equal to word 2 j. And finally, you return cache 0, 0 because you are going in bottom-up dynamic programming approach. So you return the 0th cell value. I hope the code is clear. Subscribe to my channel for similar videos every day on LeetCode. Thank you.